Hey, welcome back to Physics 2 Extreme Astronomy. This is section 13, obviously one of the best sections ever because we're finally going to start talking about galaxy formation and evolution, which is, without any doubt, the best area in astronomy. And I'm not biased at all. Just like all other sections, remember you have access to the full lecture notes. In section 13, we're going to talk first about the tools that we need to understand and measure galaxies, and specifically focusing on galaxy formation and evolution. And most of it will be recapping things we already covered in the beginning of the module, and also to do with things we've covered in the previous week about stars and interpreting them as black bodies. And we'll see that once we figure out the building blocks of galaxies, it's so much easier to actually interpret them. After that, we're going to have a look at how we can describe the statistics of galaxies using a Schechter function that many of you may find confusing, but I'll try to explain and show that it's really just a combination of an exponential and a power law. And after that, we're going to have a look at the first billion years of evolution in the universe, focusing on galaxies. First of all, looking at a summary of the first early steps and the initial conditions. We'll see essentially that the universe is dominated by dark matter, but that dark matter is not enough to predict all the properties of galaxies by far. And also, we're going to finish by looking at some of the very first galaxies, how we can discover them, what we're learning from them, the quest for first generation stars, and also their potential role in the last major phase transition of the universe that we call reionization. This section will end essentially 1 billion year into the age of the universe, and then in section 14, we will continue and develop a lot of the physics that we need to understand how galaxies form and evolve.